In this problem, we're told a force of 30 newtons is applied in the positive x direction to a block of mass 8 kilograms at rest on a frictionless surface. A, what is the block's acceleration? And B, how fast is it going after 6 seconds? So this right here is our block. We know it's 8 kilograms. It's being pushed with a force of 30 newtons in the positive direction, right? So this direction is positive. And so we're trying to solve for two different things, right? So for the first part, we're trying to find the block's acceleration, right? So we're trying to find acceleration. And then we're also trying to find how fast is it going after 6 seconds. So we're trying to find the velocity, right, at 6 seconds, essentially. Right, so we're solving for two different things. Let's just start with A. So how do we solve for A? So according to Newton's second law, there's a formula you should know, which is force is equal to mass times acceleration. So if you want to calculate the force or the acceleration of something, all you have to do is, right, if we divide both sides by m on this formula, essentially the acceleration is just the force, right, the constant force divided by the mass, right? And so notice what we're given. We're given a force, which is 30 newtons, and we're given a mass. So if we want to calculate the acceleration, all we have to do is take the force and divide it by the mass, right? So it's just going to be 30 newtons divided by 8 kg, right? And so when you go ahead and do this, right, plug it in your calculator, 30 divided by 8, you're going to get 3.75. So it's 3.75, and then when you divide newtons by kilograms, it's meters over second squared, so meters per second squared. So this right here is going to be the acceleration. So this is your first part. Now let's do the second part. So for the second part, we're trying to find how fast it's going after 6 seconds, right? So we know the time is going to be 6 seconds, right? And so we also know the acceleration of the block, right? So the acceleration is 3.75 meters per second squared. And then what else do we know? So we know it's going to be starting at rest, right? They tell us it's going to be starting at rest on a frictionless surface, meaning the initial velocity is 0 meters per second, right? Because it's not moving. Right, so what should this tell you, right? So we're going to use kinematics to solve this, and you should be pretty good at that by now, right? One of the earlier chapters, but essentially, right, we have t, we have a, and we have v sub 0, and we're trying to find v, right, at this time. So we know v equals v sub 0 plus a times t, right? This is just one of the kinematic equations. So we can just plug in v sub 0, we can plug in a, and we can plug in t, right? So v is going to be equal to v sub 0, which is just 0, so we don't have to add it. So then we just multiply the acceleration, right, 3.75, multiplied by the time, which is going to be 6. So 3.75 times 6, you're going to get 22.5. So 22.5, and then keep in mind the units. This is measured in meters per second squared, and then you're multiplying it by seconds. So notice one of the seconds, right, the exponent just becomes a 1, right? Because it's like this, and these cancel. So yeah, meters per second, that's going to be the units. So 22.5 meters per second, right? And keep in mind it's in the positive direction, it's in the same direction because it's positive. And so yeah, this right here is the acceleration. So your answer to A, and then your answer to B, how fast is it going after 6 seconds? 22.5 meters per second, that's B. But yeah, so these are your answers, and hopefully you found this useful.